Okay, our next unit is going to be on something called geometric constructions. What a geometric construction does is we can create different geometric things that we've studied this year, like angle bisectors or like a tangent to a circle, without the use of any distinct measuring tools like a protractor or a ruler. Okay? So what we're going to be using is a compass, which is a tool that can be used to draw circles. It's actually a measuring tool as well because it can maintain a size, so we can find out how big something is, maybe not in terms of inches or centimeters, but in terms of this big. And we just kind of open it up to this wide. And it can hold that measurement for us. And then we're going to be using a straight edge, which could be a ruler, but we're never actually going to use the markings on it. So a straight edge could also just be like an index card or the side of a notebook. It's just something that we need to be able to trace out a straight line on. We're not actually going to use any of the unit markings on it. And from those, we're going to learn to do several different constructions. We're going to have 7 days of lessons, we can see here. Typically, we're going to be learning about 2 constructions a day. There will be a quiz on day 5 and then a quiz on day 8. So that first quiz is going to be the Wednesday that we come back from spring break. And then the other one will be, I think, the following Tuesday. This project as a whole is not due until April 25, which sounds really far away, but we have a week of spring break in there, we have Good Friday in there and stuff like that, so we get a couple little divisions in there. But the project is due, I think it's like 3 school days after we complete the lessons. That gives you a little bit more time after we're done to get caught up on stuff too. There will be daily assignments, but they will not be collected daily. I have taught this class for 9 years. I can tell you with a lot of confidence that if you choose to procrastinate on your assignments, you will do poorly. Every year I have students who decide to challenge me on this, and they've never proven me wrong. So you might think that you can, but I'm going to tell you that I have 9 years of students who have not been able to prove me wrong on this. And I took this project from somebody who had been teaching geometry for over 30 years and had never been proven wrong. That procrastination will not serve you well in this project. So even though the assignments are not going to be collected daily, please see them as being daily assignments. Okay? You are going to turn everything in all at once then at the end in a notebook. And I'm very specific about what I want this notebook to look like. Yeah.
Okay, I haven't had a compass yet. How much are they, you said?
Between like $1 and $7. It's not a big investment. I'm going to be very specific in the way that I want your notebook set up, and this kind of outlines what I'm looking for here. The very first thing that's going to go into your notebook is the grading sheet, which I also passed out to you. The grading sheet is, guys, the grading sheet is this sheet of paper. At the top here, it tells you which problems you're going to be doing each night. So those are the 7 assignments that you'll be doing. So you'll want to hold on to it for that purpose. But then this is also where I'm going to put your score. So this should be the very first thing inside your notebook. If you're using like a spiral notebook, you could just tape it right inside the front cover or right to the first page of the notebook. If you're using a 3-ring binder, you can hole punch it as the first thing in there. If there's a pocket in the front of your notebook, you can just put in the pocket. But this needs to be right in the front. It's going to have your name on it. And this is where I'm going to put your rubric score. So you can see what I'm going to be looking for. If a problem is not done, completely skipped, like you just didn't do the problem, you're going to lose 2 points. Okay? Problem not done correctly means you tried something and it was wrong. But you tried something, you're only going to lose 1.5 points. Okay? Accuracy errors come in where you tried something and it was kind of right, but you maybe did part of it wrong. So something's right about it, something's wrong about it. We're going to lose some accuracy errors. And those, you could lose more than one of those on a problem. So you could lose maybe 2 accuracy errors on a problem to lose 1 point out of the 2 points for the problem. Or you could be that you did everything right about it, it's just off a little bit. You were supposed to create an angle bisector, and it looks like you did it all right, but it's definitely not in the middle. So something's a little bit wrong about that. You would lose 0.5 point there. Creativity subtractions are going to come from coloring or your cover page if those aren't kind of up to par, and I'll talk more about those when we go back to what I'm looking for in the notebook. And then it's total out of 100 points possible. This is a very large grade for us. I don't think anything else all year has been worth 100 points at once. There's a reason why it's so many points. It's 7 homework assignments. Typically, homework assignments are worth 10 points each. So that's like 70 points, okay, right there. And we're not going to have a test on this. We're going to have the 2 small quizzes. But so that's why this is worth so many points, is it's 7 homework assignments and kind of acting as a test or project grade. So this is a very large grade for us, and it can do a whole lot to either create a good or bad fourth quarter grade. So please take it seriously in that. So back to what I'm looking for here. The very first thing in there should be that grading sheet. Then the next thing I should see should be a cover page. Some students are more artistic than others, and I'm not a very artistic person. So on that cover page, we're looking for something with straight lines and circles, okay, some sort of a geometric type thing, since this is geometry, and in constructions we're talking about straight lines and circles. So I have some student samples here, just straight lines here on this one, colored in nicely. Some students are much more creative than other students, or spend more time on it and make really nice projects. Some students are not as creative. This is the notebook that I made, and like I said, I don't have the art skill. My father's an artist, and it did not pass on to me. But, you know, just straight lines and circles, just something as an introduction to your project, okay? So that should be the first page of your notebook. So when you begin your assignment, leave at least 1 page blank at the front. You might want to leave a couple blank in case you start doing something and you're like, oh no, I don't like this, and you want to rip it out. You want a couple more there. So start your assignments maybe in a few pages to your notebook so you have room to do that cover page as the first thing I would see after the grading sheet. At the beginning of each assignment, you should write at the top of the page the problems that you will be doing for that part of the assignment. So up at the top, just write out assignment number 1 and what problems you're doing, assignment number 2 and what problems you'd be doing, okay? Do only about 2 to 3 problems a page. So I think somebody in first hour counted out how many problems you have to do, and that's it's going to be about, 25 pages or something of problems if you do about 2 to 3 problems a page. The reason why is not that I want us to waste trees or anything, but if constructions get very small, they get inaccurate and they get sloppy. So we need to think about doing them kind of in a medium size. Some of the early ones you might be able to fit 4 on a page and have them still work out fine. But as they get a little bit more complicated and there's a little bit more going on in the problems, about 2 to 3 a page is all we can really fit in there and have them look nice and be accurate. So about 2 to 3 problems a page.
Can you go front and back on a page?
No. So the next thing is don't use the backs of the pages. The reason why we're not going to use the backs of the pages is a compass can often make a mark through a paper. And so then if we're doing something on the front and the back, that can interfere with it. And also the other reason is that you're going to be coloring at least your answer in. And if we color on the front and back of the page, that can start to look a little bit sloppy and distracting as well. So just do your problems on the front of the pages. And write out the problem as it is on the assignment sheet. So your very first problem from tonight's homework is draw an obtuse angle and bisect it. Write out those words. Draw an obtuse angle and bisect it. And then do it. Okay? One of the reasons I ask you to do that is because if you do the problems out of order then, that's okay with me, but then I can see what it was that you were trying to do on that problem. So write out the words that the problem sheet asks you to do as well. Don't erase any of the marks that we make for the construction. I'll talk more about that once we actually get into what our constructions are for today. And then coloring in at least your answer. Some students choose to color in their whole picture. So this student began coloring in a lot, and then here, nope, coloring's taking too much time, and went to just coloring in the answer, and that's totally fine. So your answer is often just going to be a line, or maybe a circle or a triangle, but just kind of highlighting out the answer is necessary. Coloring in more makes it maybe prettier, but it's not necessary. So you can choose how much you want to color in your project. All right, so the other sheet that I gave you is your problem sheet. So Mine sideways, but this is what it looks like. At the top of each column is a Roman numeral. So this is Roman numeral 1, and then there's 2, and on the back, Roman numerals 3 and 4. On your assignment sheet, notice that it tells you a Roman numeral first, and then the problem numbers there. Okay, so we'll be using just that one page of problems for all of the lessons, and then pay attention to which part of the sheet you should be doing the problems from. Any questions on just kind of the project in general? Okay, then let's start learning some constructions. Using a compass is a skill. You know, when you're in like kindergarten and first grade, you learn how to hold your pencil properly and how to use scissors, and those are all very difficult things for small children to learn to use those tools. And using a compass is a skill. One suggestion is to use the fact that you are using paper to your advantage. When I work on the board, I can't do this really, but when you're using paper, some people find it easier to hold your compass still and turn your paper around in a circle. Some people are fine just twisting your compass around. Some compasses have locks on them. They might have kind of like a crank or something that sets the size, or that you lock a compass to a specific size. Some don't. They're called self-locking, and they're supposed to maintain their size, but they don't always. One suggestion is to put more pressure on the point of the compass and then just lightly drag the pencil. It doesn't have to be really dark. The marks that we make don't have to be really dark. They just have to be visible. Okay? So put more pressure on the point and less on the pencil will help it drag more smoothly around and make a better circle that way. But there is definitely a skill to doing this, and it takes some time and some practice to kind of get that down. Our first construction we're going to learn today is how to copy an angle. To copy an angle, you're going to use your straight edge.
Is there somewhere to take notes?
Yeah, good question. I would definitely suggest taking notes. And one strategy for doing that, a good place to put them, is in the back of your notebook. So if you start your notes at the back of your notebook and start your assignments at the front, you definitely won't even meet in the middle. So that would be one way of doing it, is to just start your notes at the back, or you can take them on whatever paper you want to take them. I'm never going to check your notes, but it would be a good idea to take notes for sure. So our first construction is copying an angle. So first thing you're going to do is make an angle that you want to copy, and then make a line that you want to copy that angle onto. So our goal is to take however big this angle is and make the same exact size angle in another location. Okay? We are not using protractors, so we're never going to actually know how big this angle is, like it's 23 degrees. Okay? We're never actually going to know how big this angle is. But we want to take this angle, however big it is, and move it to a new location. This construction is exactly the same no matter how big the angle is. So acute, right, obtuse, same exact construction no matter how big the angle is. Sometimes the problems will specifically tell you to draw one type of angle, so then you will want to do that. Otherwise, I tend to think about Goldilocks a lot when I do constructions. If we do things really tiny or really big, they tend to become inaccurate and sloppy. So always kind of go for medium size when you have a choice. Okay. Our first step in copying our angle is to make an arc on the given angle. Typically, you're going to want to put your compass point onto important points. An important point of an angle is its vertex. So I'm going to put my compass point on that vertex, and I'm going to open up my compass to some, again, Goldilocks kind of medium size, and I'm going to make an arc. I don't know if this is going to work. So open up your compass to some kind of medium size, put your compass point on the vertex of the angle, and make an arc. Keep your compass that same setting. Okay? An important thing about a compass is it can hold a size. So I want to use that size that I just had, and now I want to put that same exact size mark down where I want my new angle to be. So I put my compass point at the vertex of the angle and make a Goldilocks size mark, put it down where I want my new angle to be, and make the same exact size mark. Okay, we're measuring a distance here. So step 2, make same arc on line. Sorry, I know that's hitting the tack board because I have the screen up. Probably put the screen down. Now what we want to do is know how wide this angle is. So a compass is a measuring tool. So what we're going to do is anytime that you make a mark with your compass and it intersects something that's already there, we're going to place a point, and those points are going to become important to us. So what I'm going to do is place my compass point on one of those points and use my compass to measure how wide that angle is. So I'm going to put my compass point on one of those points and put the compass pencil on the other one to measure out that width of that angle. So it looks something like that. Okay, so compass point on one of the points across the arc and compass pencil on the other one. And then I'm going to take that down to our second arc and make that same size marking. Okay, so putting your compass point down where we want the new angle to go, I'm going to make that same size marking. So I use my compass to measure how wide is the arc, and then I take that width and bring it down to where I want my new angle to be. Okay, so 2 things we're going to think about a lot when we do these constructions is Goldilocks and doing things on medium size. And the second thing that we're going to think about a lot is pirates. And X marks the spot. Okay, so when you get an X, that's going to be an important thing for us. And in this problem, that X is going to mark our answer. That if we connect that X to the vertex, those 2 angles should be exactly the same size given some human error. Okay, human error is definitely going to be a part of this. So when I grade your notebooks, I'm not going to take out a protractor because you're not using them. So I'm not going to take one out and be like, oh, this angle's 23 and that one's 24. Wrong, right? I'm going to say, does it look about right? Then it's going to be good. And most importantly, are the correct compass markings there? So never erase a mark that you make with your compass unless it's wrong and you're starting over. Okay? Otherwise, the marks your compass is making are important marks. So our third step was measure width of angle, and then copy that width and connect. Okay. So I'm going to be looking for those exact compass markings on your assignments.
So for this type of problem, in our homework, would we have to color that entire second angle?
It's a good question. So what do we color for an answer? So you have a couple of options. Some students like to, since you're using, you could use colored pencils or crayons. Some students like to kind of shade in this whole area. If you're doing markers, that looks pretty sloppy. But if you can kind of shade in that whole area, that's one way to color your answer. Another way that some students like to color an answer is to take a colored pencil, a marker, a highlighter, just something, and color the angle, just kind of trace out the lines that you've made. Okay, so you do need to color your answer. Your answer on this one would be the angle, so you can choose whether you want to kind of shade in the angle or whether you just want to trace out the angle. Okay.
Will you get points off if you don't color it?
Yes, if you don't color, there will be deductions. Yep. If you choose to color more or color less, that won't necessarily make a big difference in your grade. But if you choose to not color, there will be deductions. Our second construction for today is going to be to bisect an angle. Oops. So to bisect an angle, we need to start with an angle. Once again, kind of Goldilocks, medium-sized angle, and the construction is the same whether you do an acute, a right, or an obtuse. So your first problem on your assignment tonight is draw an obtuse angle and bisect it. So then you would do an obtuse angle, but the steps of the construction are the same. Our first step is going to be to make an arc across angle. Okay, once again, we usually want to put our compass point on an important point. The important point of an angle is its vertex. So I'm going to put the point of my compass on the vertex and make a mark across it. When you make a mark, then I like to emphasize the points of intersection. So that arc intersected both sides of the angle, so I'm going to create some points there. Points are places where we're going to put our compass point. So what I'm going to do next is put my compass point on one of those points, it does not matter which one, and make a mark. It doesn't matter what size your compass is. It could be the same size you already did, or it could be a new size, but just make a mark inside the angle.
Just a random mark.
Just a random mark, but once you've done that, keep your compass that size now. Okay, so that mark could be any size, but now we want to maintain that size. So step 2 is from intersection, make arc. Step 3 will be make same arc. Sorry, really bad handwriting here.
Writing with your finger.
From other intersection. I'm writing with my finger, and usually I blow it up, so it's better, but if I blow it up, it's going to change the scaling of my drawing, and then the whole idea of a compass won't work anymore. So now I'm going to make the same arc from the other point. So I'm going to put my compass point down at the other intersection and make exactly the same size arc as I did before. And we are thinking like pirates when we do this. So X marks the spot. And I'm going to then connect that X to the vertex. And that should be our bisection of our angle. So those two angles should be exactly the same size. Again, give or take human error. And I'm not going to measure your human error. But if I look at it and I'm like, one of those is clearly larger than the other, there will be a deduction on that. But make sure you leave all of your compass markings there so that I can see that you did the problem appropriately, even if it doesn't turn out to be quite accurate. In terms of coloring this problem, what's colored in red would be the minimal. Okay? So just drawing in the bisection itself and highlighting that ray would be the minimal. Some students choose to kind of color the top angle one color and the bottom angle another color, something like that. And you could do that as well if you want to shade in those angles. But just kind of highlighting that bisection line would be the minimal coloring.
What you're doing in purple, do you want us to do a different color too?
You don't have to highlight out the marks from your compass as long as I can see them. If they're really faint and you think I might not be able to see them, then you might want to highlight those out for me too. Okay? All right, I want to show you also a computer program that can do constructions. Some of you might want to try to do some of these on the computer, and that's totally fine if you would like to do that, and then print them out and just kind of tape them into your notebook would be fine to do. This program is free to use online, or you can download it for free. If you have a school computer, it is already on it. There is an app, so you can do it on an iPad. I don't know if you could print it really well from an iPad, but the app is free also. So if you do have like an Apple printer or something, or could print it, or I guess you could like save it as a PDF and email it to yourself. Email it to yourself and print it if you want to do that. That's fine. Yep. Okay, so this program is called GeoGebra, and again, it is on your school computers if you have a school computer. Otherwise, you can easily get it on a home computer if you would like to give some constructions on here a try. So our first construction we learned today was how to copy an angle. So to do that, I'm going to grab my line tool up here, and I'm just going to make an angle. And then I need a line that I'm going to copy that angle down onto. Then our first step of copying an angle was to make a mark across our angle. So I'm going to go grab my circle tool, and I'm going to use the circle to make a mark across that angle. Anywhere I get an intersection, I'm going to add a point. So I'm going to grab my point tool and add a point there where I get intersections. Those will be important. Then we wanted to make exactly that same size mark down on the other line. So under the circle menu, there is a tool that's called compass. So we want to use our compass. And first we're going to measure how big this circle is. So I'm going to put my compass at the center and then out at the edge of that circle. And it gives me a circle that's exactly that same size that I can place anywhere I want. And I want to place it down on the other line. Again, when I get an intersection, I'm going to make a point. Then we measured how wide the angle was. So I'm going to use my compass to measure how wide our angle is. So I'm going to place my point at one side and click, and then at the other side and click, and it gives me a circle that measures that width, but I can put this circle anywhere. So I'm going to put it down here. I got an intersection, so I'm going to put a point. And if I connect the points, I get a new angle that is exactly the same size as the other one. And one of the fun things about doing it on a computer is we can see that they really are exactly the same. I can tell it to measure that angle and measure this angle. And it always puts it in kind of an inconvenient place where you can't really read what it says. But I'll drag those down. I can see they're both 21 right now, but if I take my arrow and I grab and I move around some points, it doesn't matter where I move it around. Those two angles are always going to be exactly the same size. So there wasn't anything special about the size of the angle that I did. This construction will guarantee that they are always exactly the same size. Even if I would take it out to an obtuse angle, they're still going to be exactly the same size. Okay. The second construction that we learned today was how to bisect an angle. So to bisect an angle, I'm going to start with my line tool, making an angle. Then we put a mark across our angle. And again, anywhere I get an intersection, I'm going to add a point in with my point tool. Then we made a mark, and it didn't matter what size, so I'm just going to use my regular circle. I made a mark that went somewhere inside, and I can make it whatever size I want. But then, using the same size, so now using my compass tool, I'm going to measure how big that circle is that I just did, so I get exactly the same circle, but I want to locate it down at the other side of the angle. Where I get this intersection, I'm going to get a point. And if I connect that to my vertex, we get the bisection. And again, I could tell it to measure it and prove that this is actually halfway, but as I move it around, we can see that it's always staying right there in the middle. I like this program a lot for the ability to be able to actually take the measurements and show this really does work. I like it for these earlier problems where it looks kind of cool. As we move forward and our constructions have more steps involved in them, I don't like this program as much because you can't just do a mark. You have to do the full circle, and it can become very overwhelming. The more circles we get in these, there's kind of a lot going on in here. But we can see as we change the size of the circles or we change the size of the angle, it doesn't change the construction. It's always still a bisector.